I am going to be talking about electric propulsion today. There's a whole host of different facets to the topic, so I'm going to try and cover them all in a sort of a broad sense. As Glenn said, there's a lot to get through, so it's going to be split into two with questions at the end of each section. So, Oceanvolt, in a nutshell, we're a Finnish company. And we manufacture complete electric and hybrid propulsion systems. So electric propulsion it's not just about the motor so much, it's about the entire power system on the boat, because it's not the only thing that runs on electricity, obviously. We've been around for a while. We're coming up to 20 years of being in business. Our headquarters are here in Finland. I'm at head office in Helsinki. We have 23 employees. We have a US subsidiary company or daughter company, and there's more than 500 yachts around the world sailing at the moment with Oceanvolt systems on board, and we have a global sales and support network. But being electric, most of the support can be done remotely, which is wonderful. We work with a number of boat builders. In fact, almost all major boat builders in the world. If you're buying a new boat, you can ask for an electric system instead of the diesel, and they will put an Oceanvolt system in for you. So this is just an example of some of the many boat builders who are partners of ours, and we're very happy to work with them. We're seeing a massive increase in the demand for new boats with electric propulsion, so that's really encouraging to see, and we certainly enjoy working with all of these partners and all of their individual requests and requirements. It's always fun and keeps things interesting. So Glenn gave a bit of an introduction about myself. I am originally from Sydney. I've done a lot of different kinds of racing, including 18-foot skiffs, match racing out of the CYC. I've done yacht racing and things like that. I've now been working at Oceanvolt for a little over 2 years, and I'm the area sales manager looking after Asia, the Pacific region, Turkey, South Africa, Greece, and the Baltic area, including Poland. So quite a lot of the planet to look after, but in my opinion, the best countries. It means I get to visit home every now and again. So electric propulsion, it's not for every boat. I'll say that straight away. For instance, if you've got a big Riviera and you like doing 20 knots up and down the Lane Cove River, much to Karen and my chagrin, electric propulsion isn't for you. Those sort of boats really do need the power that diesel or petrol can supply. But for sailing yachts especially, electric propulsion is ideal, as well as smaller, lighter displacement motorboats. The things to consider are the range. So with pure electric, we typically don't recommend a system that has less than a day's worth of motoring for a pure electric boat. Obviously, you can put as much battery power on as you like, but with pure electric, we're all sailors here at Oceanvolt, so we know how most people use their boats. So we don't put a ridiculously small amount of battery power on board. We make sure that you've got enough power to do what you need to do. And we also do hybrid options as well. If you need the extra range, if you plan to be motoring for a couple of days on end through a light weather patch, for instance, or you want to have that extra security that you're not going to be touching on shore for a couple of days or weeks, then we do offer hybrid solutions as well. Other things, if you're going to be refitting your existing engine, or if you're going to be buying a new boat, a brand new boat with electric inside. So in general, as a general rule of thumb, an electric motor is roughly the same cost as the equivalent sized diesel. So the idea that electric is so much more expensive than diesel is a little bit unfounded, or it's not the whole story. It's the batteries that you then need to get on top that typically make people think that the whole thing is so super expensive. But if you separate the two into the propulsion system and the battery system, it becomes a lot more manageable to think about, but also it enables you to consider the fact that you're not just getting a big battery for your propulsion system, but it will also be able to supply all of your house electronics as well. So that means, virtually unlimited use of your air conditioner or your heater or your jacuzzi or your plasma screens or whatever it is you have on the boat. You don't have to worry so much about, how much power you have in your batteries because you have a nice big battery. But it can sometimes make more sense if you're interested in going electric to buy a brand new boat with electric already installed versus refitting. Refit will always be a part of Oceanvolt's business. That's where we started, and that will always be a part of our business. But there are these two sides, obviously, new builds and refits. So different kinds of electric motors. This is just like as a general bit of education for everybody, the different terminology. So there's a sail drive motor, which is on the far left, obviously, where the electric motor itself is inside the boat. And then you have the sail drive leg underneath, just like a standard diesel would be. There's shaft drive systems, which obviously pretty self-explanatory. They go, those two black boxes go exactly where your diesel would be, and you have your shaft output here. Then there's the outboard motors. Everyone's pretty familiar with an outboard, but then a pod motor. So the pod motor and the sail drive motor tend to get confused. A pod motor is the sort where the electric motor is actually in line with the propeller underneath the water. This has some pros and some cons. There's pros and cons to all of them, but between the pod motor and the sail drive, it makes the installation a lot easier with a pod motor compared to a sail drive. As you can see, there's very little that's coming in. However, having a motor underneath the water where it could be susceptible to striking a log or something and opening the casing is something to consider. Whereas with the sail drive, the electric motor is inside the boat, and it's a two separate things. So you have the leg and then you have the motor, which can obviously have its own advantages as well. Oceanvolt supply these two systems on the left. So we supply sail drive motors and shaft drive motors. We don't do outboard motors or pod motors at this stage. But almost any boat between 30 and 70, 80 feet in length we have systems that can supply plenty of propulsion power for your boat, no matter if it's a shaft or a sail drive. So this is what a typical Oceanvolt electric propulsion system would look like. And it looks kind of confusing, so I'll walk you through it. Basically, this is a hybrid system. So number one here is a DC generator, and I'll come back a little bit to DC and AC generators, because I'm sure that if any of you have a generator on your boat, except for Guido, it'll be an AC generator. And I'll talk a bit more about why we use DC generators later on. The number two, obviously, is your propulsion battery bank. So this is what 46.8 kilowatt hours of battery power looks like. And this is plenty of power to get, a 45-foot yacht, maybe even 2 or 3 days worth of motoring, probably close to 50, 60 miles at 5 knots of speed, roughly, obviously, depending on the size and shape of your boat. But that's what your battery bank looks like. Then it goes into number three, which is the battery management system. And this is actually the really critical part of the whole battery system. I'll talk a bit more about batteries later on, but just be aware that the battery management system, or BMS, is really the critical part, because that is what is managing the safety and the health of all these batteries. That then goes into number four, which is a bus bar. That just divides power back and forth to either side. Number five is your charger inverter. So this is what you would plug into shore to charge your system up, but then also this supplies your onboard 230 volts for your onboard power as well. Then number 15 is a DC-DC converter, which converts down to 12 volts for your house battery, which is number 16. So as I mentioned earlier, you're putting a big battery bank on board, and it should all be integrated, or it's our belief that everything should be integrated as opposed to having everything separate. Why would you have two big battery banks when you can have one big battery bank? So typically, for refit cases, we would recommend that you can almost half the size of your house battery bank because you don't need to store that much power at 12 volts or 24 volts. If you're storing a lot of power at 48 volts, why do you need to store a lot of power at 12 volts? Because the way we configure the system is that it's constantly supplying a charge to your 12 volt side. So that's what the DC-DC converter does, is it steps the voltage down from 48 to 24 or to 12, depending on what you have. And that means that all your 12 volt components take their power from the battery, but the battery is being constantly charged by the 48 volt side. So that means you have one shore power plug to plug in, and that charges the main battery bank, which supplies power for everything else on the boat. So everything goes into the main battery bank and everything comes out of the main battery bank. It just makes things much simpler. Speaking of which, solar, we strongly recommend solar, especially down in Australia where solar actually works really well. Things to keep in mind if you're doing a refit and you already have solar panels on board, is it's most likely that your panels will be configured to supply your 12 volt system or your 24 volt system. You can keep it that way to supply your house battery, but if you want it to fill up your 48 volt battery, then some changes need to happen in your MPPT, because a lithium battery requires a relatively high charge voltage. So a 48 volt battery bank typically requires, I think it's 56.4 volts of incoming power before it will accept the charge. So there's two ways of doing that. First way that you're probably all thinking about is, well, you just link all your panels together and then you get, 60 volts. But if you get shade on one of those panels, then it won't work. You lose it, everything out of the panel. So what we supply is, or we can help with, and we can supply solar charge kits, which basically works as a voltage booster so that each individual panel can supply power to the 48 volt battery bank. So that's just something to keep in mind. Then we start getting to the interesting bits. So obviously over here we have our propulsion motor. This is connected to the motor controller, which has its own cooling system. Both the motor and the motor controller have cooling systems. Typically they are separate, but we have a number of different cooling systems. Oil to air, oil to seawater, depending on what it is that you want. Or here we have a keel cooler, which is a closed loop system where this little fin is on the outside of your hull like a blister, and the cooling fluid goes through it and just disperses the heat out to the sea. Then we have the Oceanvolt display here, number 11. So this is typically by your helm station. This will show you how much power you're using at any given time in kilowatts, what your RPM of your motor is, how much battery power you have, as in like a graphical display of your battery, just like on every other electric device that you have, like your phone, it has like a battery symbol. It also shows you how much time you have left at your current rate of consumption, but also when you're charging, it shows you how long it will take to charge your battery at the current rate of input. There's only one button on it, but there's a few screens you can cycle through, and if it's a complete system, so a complete Oceanvolt system, and I'll talk more about that later, but if it's a whole system supplied by us, then you can see all the battery data as well on that screen. So what the individual voltages are of each module, and the temperature of the various different things as well, all shows up there as well. And also if you're regenerating, so charging whilst you're sailing, and I'll talk more about that later on. That also all comes up on your screen there. The whole thing's operated here. Number 12 is another screen. This is sort of a whole system management screen. And this is typically by your navigation table, or wherever else you have all your switch panels and things. And that also shows a more large scale overview of your whole system. So how much solar comes in, how much the generator is doing, and things like that. And it's a touch screen, so you can also operate a lot of the system from here. So you can turn the generator on or turn it off, or things like that from here. Number 10 is your control lever, obviously, so your throttle lever. It's a really, really nice unit. It's got a really nice feel to it. It's super slick. It's a really nice piece of design. And number 12 is the remote system monitoring and diagnostics, which I'll talk about at a later point. But that's basically what a whole system looks like. As you can see, the generator is sort of just by itself. If this were a pure electric system, we would simply delete the generator and maybe put a couple extra batteries in, and nothing else would really change. So it is very simple to change from one type of system to another, from hybrid to pure electric, because the generator really is just a modular drop-in sort of element. So it is very simple to modify. So if you want to start small and then later on you want to increase the scope and the capability of your system, that's very simple to do. So now we're getting to a little bit more of the technical stuff. So whenever you guys are talking about your diesel engines, it's always how many horsepower you have. Horsepower is, in all honesty, a pretty archaic way of measuring the effectiveness of your engine. I believe horsepower is technically the amount of weight that a single horse, the amount of horses it takes to lift a certain weight over so many yards or something. It's ridiculous. It's not a very accurate way of measuring the effectiveness of an engine, I'll put it that way. So what we use is kilowatts, which is it's a metric measurement, and it's more accurate way of measuring how much power is required, because it's not so much about horsepower as it is about torque. Power doesn't move your boat, torque does. Torque is the force, whereas power is a different thing altogether. So most boat builders would recommend 4 kilowatts per ton as a guideline if you're going with electric, or with whatever propulsion you're using. But with Oceanvolt, we recommend between 1 and 2 kilowatts per ton. And this is because, as I said, it's the torque that's moving the power. And with an electric motor, you have so much more torque through the revolution range. It's a much more stable torque graph as well. And also, the other reason why we don't need to recommend such a high amount of kilowatts for a boat is because our motors are designed specifically for the marine environment, specifically for use in boats. Quite a lot of other electric propulsion systems out there typically repurpose motors from forklifts or agricultural or industrial equipment. And yes, an electric motor is an electric motor, but if it says it delivers 10 kilowatts, then it probably does deliver 10 kilowatts. But the question is how it delivers that torque and that power. So that's why we design our motors specifically for use in boats to best use that torque, because a forklift and a boat use the power very, very differently. How much does the hull require power? So this is where we would do a power or resistance calculation. So on our website, we have a configurator where you can put in the waterline length of your boat and the displacement, and it gives you a very basic rudimentary version of this graph telling you how much power it requires to achieve what speeds. And then for when we get a lead in and we start talking a bit more seriously, we can make a custom resistance calculation for your specific boat. So this one here is for the new X-Yachts XC47. And this is just simply how much power is required to move the boat at various speeds. It's not related to electric propulsion, this calculation. This could be jet propulsion, it could be nuclear, it could be coal, steam, diesel, electric, anything. This is just simply how much power is required to move the boat. And as you can see, it's exponential. So the faster you go, the more Mother Nature tries to stop you, as we're all aware. So that's why we try not to, if people want to be motoring at 10 knots, then you're better off with a diesel, because when you're using a diesel at the top end of its rev range, that's where you have the torque and the power. So top speed is better for diesel, but electric is better for low down torque. So as you can see here, it doesn't really require too much power to get this boat moving. At 5 knots here, you're using 5.5 kilowatts of power, which is extraordinary for a 47-foot cruising yacht. So that's something to sort of get. It can be a bit of a challenge to wrap heads around, is to talk about kilowatts versus horsepower. So this is an example of the torque curve for an 80 horsepower Yanmar diesel engine. As you can see at the low end of the revolution range, as I'm sure you all know, if you just clock your diesel engine into forwards, but leave it at idle speed, you can stand on the dock and hold your boat back with one hand because there's not much torque down low. You have to spin the engine up quite high to be able to get the torque you need. But then up here, as you can see, this is our 25 kilowatt high power servoprop, right from the very beginning of the revolution range. So from 1 revolution per minute, you have all of that torque available right up to the upper end of your of the rev range. So that means, for instance, punching through headwinds, you're much better off with an electric because you have the torque available at any speed. So as I mentioned earlier, diesel has a higher top speed. So and there's nothing wrong with wanting to motor at 8 knots. Absolutely nothing wrong with that. And if that's a requirement for you, then I'm more than happy to say that diesel is the best option for you. Or if you're desperate to have an electric motor and you want to do that high speed, then you would need a high voltage motor, which is not something that Oceanvolt does. We typically only supply low voltage systems. So all our systems run on 48 volts, and there's many reasons for this, but chief among them is 48 volts is incredibly safe, and you don't need to be a qualified technician to work on it. If you get a high voltage system and you have a problem, you're not allowed to touch any part of the system unless you're a qualified marine electrician with a special high voltage ticket, which can be quite difficult to find if you're cruising off the coast of Fiji, for instance. So we use 48 volts, which means the lower speeds for yachts between 30 and 70 feet is really where Oceanvolt fits into the market. But yeah, it's pretty self-explanatory. If you're into high speed, then stick with a diesel. But really, we're all sailors here. So when's the last time you drag race your boat under engine? The next topic, bit of a shift, is hydro generation. So I'll talk about this a bit, and then we'll take a break and have some questions. This is the big question, or the big topic rather, for electric propulsion. And this is where Oceanvolt really excels. So all electric motors are capable of hydro generation. It's how electric motors work. If you put power into an electric motor, you get motion. If you put motion into an electric motor, you get power. So all electric motors by nature have the capability to generate power whilst you're sailing. However, very few can control it, and we're the only ones that are actively focusing on it. So therefore, your Oceanvolt electric propulsion system is 2-in-1. It's not just propulsion, but it also gives you the option to recharge whilst you're sailing. All of the Oceanvolt motors have regeneration as a feature. That's a standard feature, even if it's a shaft drive system. But because the propeller has such a big impact on the effectiveness of hydro generation, shaft drive system is going to be less effective than, say, our servoprop. So our servoprop, which I talk about straight after this section, has the highest rate of regeneration out there. There's nothing that can even compete or come close to the amount of power that it generates. Hydro generation is a function of your speed. So as you can see, the faster you go here, the more power you generate. So at 8 knots with our high power servoprop, the XC47 was pulling in 2.5 kilowatts of power, which is really, really impressive. And at 9 knots, it was 3.5 kilowatts of power. So the high power servoprop is a really effective regeneration machine. And this is not a prediction. This is actual data from the XC47, which, as you can see, matches very closely to our predicted line. So we try really hard to make sure that we don't overpromise or inflate our figures. We're very open about the figures that our systems can do. And that's something else that sets us a little bit apart. Is if you're interested to find out how much power you can generate at various speeds with a certain system, we're happy to tell you what that figure is likely to be based off hundreds of boats of data, and customers are happy to share that data with us, and we're happy to publish it. So we're not hiding anything like that. We're all about pushing electric propulsion forwards as a whole. So we're very transparent with that. Drag is the big question of hydro generation. Drag is very dependent on the hull and the speed. I could have a whole other talk about hydro generation and how to best maximize it. But essentially, it comes down to how much power you have in the boat from the sails. So for instance, if you're sailing upwind in 7 knots of wind, you're not going to be going very fast, and you're not going to have an excess of power, right? So that means that if you turn on hydro generation, you're going to get quite a bit of drag. However, if you're on a beam reach in 15 to 18 knot, beautiful Sydney Harbour sea breeze, you're probably going to be reaching for the Cunningham, maybe dropping the traveller down a little bit. You're going to have an excess of power. So that's where the regen is very, very effective, where you'll have a very low amount of drag. So as you can see at hull speed for the 47, the drag penalty was a max of 0.5 knots. And that can also be, is also influenced about which angle of sail you're doing. So upwind, obviously, there's going to be more drag than if you're on a reach or if you're going downwind or anything like that. So there's different ways of maximizing it, but typically with a smaller system, so say a servo prop 15 or a 10 kilowatt servo prop, in the right conditions, you'll be less than 0.1 knot of drag from hydro generating, and you'll be pulling in a kilowatt, maybe 2 kilowatts of power. So yeah, hydro generation is a very effective way, but it really only starts at about 5 knots. If your boat's going less than 5 knots, then I'm willing to bet you're not at your hull speed, which means you don't have this excessive power. So we don't allow our systems to do regeneration below 5 or 6 knots. If your boat speed drops that low, then the system will turn the regeneration off automatically for you. So it's really only effective at the 6, 7, 8 knots is great. Or if you have a multi-hull and you're doing 18 knots, then you'll be creaming in the power. But yeah, that's a little bit about hydro generation. All right, so we'll keep going. Servo prop, great introduction. So this is our own patented, award-winning invention. Essentially, our guys were sort of thinking, hey, this regeneration thing is great. How can we make it better? What's the limiting factor? It's the propeller. So how can we get control over the propeller? So what they did is they invented this. It is a controllable pitch propeller, which means that in this design, in servo prop in general, the pitch angle of the blades is controlled and adjusted by the onboard computer and the software. So when you're not using your boat, or when you're sailing and you want to turn your engine off and just go sailing and not regenerate, the blades rotate so that they are in line with the water flow, which means that you're not getting really any drag at all. In fact, some of our researchers and tests have shown that it has less drag than some folding propellers even. And then as soon as you put it into, say, forward propulsion mode, so you just put the throttle lever into forwards, the blades automatically rotate into the optimum angle to give you the best forward propulsion. Now, this means that you're going to be getting 30% better forward thrust because the blades don't need to unfold, and we can remotely set the pitch angle that is specific to your boat that works best for your boat. So you'll be getting the ideal pitch when you go into forward thrust. Now, when you go into reverse, the blades rotate the other way to give you the exact best pitch to go in reverse. Now, any one of you guys who has a boat that has a folding propeller, I'm sure you can agree, reverse typically sucks with a folding propeller. If you go with a servo prop, you get at least 100% more reverse thrust because you have the same amount of thrust in reverse that you do in forward because the angle of the blades is set to be at its ideal pitch to give you that thrust. And then the figure 300% better regeneration. Again, this is because the blades get set to the exact right pitch to be generating power for you. So you don't have to worry about the blades opening of your folding propeller. All around, it's a really fantastic solution. And this is something that we've been developing for years. This is, as I said, it's our own patented technology. We've been working on it for many, many years, and we're constantly evolving it and improving it. And it's super exciting. And the best part is that most of the improvements are actually to do with the software in terms of making it more active and more dynamic. And those updates can be sent out remotely. So with a diesel engine, it's never going to be as good as the day you install it, the day that it's brand new, and it will just deteriorate over time. But an electric system, it just gets better with time because we keep updating. We're updating the software, we're developing new algorithms and things to improve your system. So this is why Servoprop is the leader in terms of regeneration. Nothing comes close to it from anything else. It's partly because of the Oceanvolt software, but also because of the Servoprop technology. I'm sure you're all probably thinking, okay, but you'll probably catch more fishing nets and things because the blades don't fold away. And the answer is yes, you will potentially catch a little bit more. One of the blades is typically always behind the leg anyhow, and you have just the two small blades sticking out. So there is a little bit more there, but in terms of drag, it's far less than what most folding propellers would give you. And in the high power Servoprop 25, it also has an integrated rope cutter. Unfortunately, we don't have rope cutters on the smaller 10 kilowatt or 15 kilowatt Servoprops. But c'est la vie. That's something that we've been working on, and that's why our latest product, the 25 kilowatt system, has many more improvements. So that's Servoprop. It is a very, very interesting piece of kit. Now, unfortunately, it's not available on a shaft drive system. So if your boat is set up for shaft drive, unfortunately, you don't have access to Servoprop unless you do a major refit and convert it to a sail drive option. But it's pretty complicated to try and when you have a single shaft going out of your boat to then, have all of this mechanism going on in there. So unfortunately, Servoprop is just for sail drive options at the moment. Next slide. This is the one that I said I'd come back to, lithium batteries. So this is a big question that we get all the time, and there's a lot of different concerns and things that are going around, and there's often stories that come up that can scare people away. There are many different battery chemistries. We only supply LFP batteries, which is lithium ferrous phosphate. So Li lithium, Fe ferrous, meaning iron, and Po phosphate. This is the safest lithium battery chemistry. With the MG, so we supply two different brands at the moment. We've bench tested a lot of different brands of batteries, and we currently supply Valence, but my personal favorite is MG. MG are the best lithium batteries on the market at the moment. You probably recognize that color as being similar to Victron, and the fact is that MG used to make Victron's batteries. So a Victron battery, if you have a Victron battery from a couple of years ago, it's probably an MG battery with a different sticker on it. We did a big major audit of different battery systems about 2 years ago and tested a whole bunch of them, and MG is the one that we're happiest with. So the thing with LFP batteries is there's so many different brands out there, and I get the question all the time that, okay, I want to buy your system, but I want to use these batteries, or I don't want to buy your batteries, they're too expensive. I want to buy these batteries that I can get cheap from eBay or from this caravan store or whatever. And I know everything about lithium, and the cells are all made in the same factory and all of that. I hear it quite often, and I understand obviously people don't want to spend extra money. But the way to think about lithium batteries in general, not just for electric propulsion, but if you're going to change out your house batteries to lithium, for instance, this is important to know, is that you're not paying for the lithium cells, because yes, they probably all do come from, one of only 3 factories make most lithium cells in the world. You're not paying for the lithium cells when you're getting a lithium battery system. It's the battery management system that you're paying for. That's the most important aspect. So back when, combustion engines were only just starting to be developed, fuels and things were stored in all manner of different kinds of fuel tanks, and there were many, many fires and many explosions and people smoking next to their fueling stations and causing problems and things. And over time, we've learned to store diesel and petrol in a much more safe environment. And that's why there's not so many issues with diesel, and people think that diesel is far safer than lithium. Currently today, it's still a fact that 95% of boat fires are caused by diesel. But you really only hear about the ones that were caused by lithium because it's the new and scary technology. So the battery management system is the key factor with your lithium battery system. It is what monitors every single part of the battery, not just only to make it safe, but also to ensure that the batteries last long and don't have problems. So for instance, the MG batteries, each module has its own built-in BMS, and then data cables come out of that and go into the separate BMS model, separate external BMS. So there's 2 layers of battery management happening. And what that means is that the whole system is looking at every individual cell, and it can tell you what the lowest voltage is, which cell has the lowest voltage, what the voltage of the highest cell is, what the temperatures of each module are, the rate of discharge, the rate of charge, current flowing back and forth. Absolutely everything is monitored by the BMS, and the BMS is what is controlling all of it. So that's the important thing that you're buying when you're buying a lithium battery system. Cheaper batteries mean a lower quality BMS, and that's where the problems and risks come from. So one of the reasons why there's a bit of bad press about lithium batteries is just simply a lack of information and a lack of knowledge out there. So most of the issues with lithium batteries that have happened with boats in Australia typically over recent years have been some guy with his kitty that he takes fishing, he decides to, I'll save a bit of weight, I need to change the battery anyway. He takes out his 12-volt lead acid battery that he's just had in his boat for years, and he drops in a lithium one that he picked up at his local caravan shop and thinks nothing more of it. And the thing is, you can't treat a lithium battery in the same way as a lead acid battery, and that's where the problems start. So managing the battery is the important thing, because any kind of stored energy is potentially dangerous. Not just batteries, not just diesel. Diesel is dangerous. One spark and it all goes up. But even a coiled spring that is compressed is stored energy, and that can be dangerous. So any stored energy is dangerous, but managing it is the important thing, and keeping everything safe is the important thing. So that's why it's not so much about where the cells come from, or how much the cells cost and each module cost. It's what the quality of the BMS system is the important thing. Now, with that being said, like I mentioned, there are hundreds of battery companies out there, and it seems that there's new ones every day. And people are saying, always coming up with, hey, can we use this battery? I want to use this battery. My friend makes these batteries. These are great batteries. That's wonderful. If you want to use your own, if you want to supply your own battery system, then we're not going to stop you at all. You're welcome to do so. But the main thing that we will try and do is just to make you aware that there may be some compatibility issues, because our system wants to communicate and understand what's happening with the battery system to make sure that our system isn't drawing too much power or causing the batteries to heat up or anything. So our system needs to read and interpret the battery data, or preferably to read and interpret the battery data. But every company has their own BMS, and each BMS speaks in its own language, as it were. So there's even different plugs. It's at that level that there's different sockets and plugs on BMSs to get the data. So, and that's even before you talk about how the data is, like what protocol the data is being transmitted in. So it's the short story is our system can't interpret every single kind of battery out there. If you want to use a battery that you source locally or source on your own, then what we would do is supply a smart shunt, which basically goes in between our system and the battery system, and it tries to read or interpret the battery data or the battery state just purely by the current and the voltage that's being moved in and out of the BMS. It's a less accurate way of interpreting the data. It's sort of like being outside of a room with a cup next to your ear against the wall, trying to hear what's going on, versus being in the room and in the conversation. So you can sort of catch what's going on, but it's not going to be as integrated. And then obviously if there's any issues that are caused by a battery system that we didn't supply, then obviously we can't be held responsible for that. So that's one of the reasons why we choose to supply complete systems. It's not like, for me, it's not about, I want to make as much money as possible. If I did, then I wouldn't be working in the marine industry. I want to make sure everybody's happy and that they have I have a boat myself. And when I get on my boat, I want to be happy and enjoy myself. And I don't want to be stressing and thinking about things. So a complete system from Oceanvolt means that we've done all the guesswork and things for you. And we'll be supplying a system that we know is totally compatible and won't let you down. And things have come a long way in the last few years in electric propulsion, in batteries, and also in Oceanvolt. There's been a lot of changes and improvements over the recent years. So it's a really exciting time at the moment. But that's lithium batteries. I hope that's given some answers. I'm guaranteed there's going to be more questions on that later on. But for the moment, I'll move on to generators. So I mentioned this briefly. Most of you who have generators on your boat, I guarantee they will be AC generators, and they work fine. They are variable speed typically. So the more power you need, if you turn on your jacuzzi and your plasma screen, the generator will spin faster to produce more power, which sounds really great, sounds really fuel efficient. But the reality is that a DC generator is a much more efficient way of running your boat. The way a DC generator works, very briefly, in an Oceanvolt system, is the DC generator makes 48-volt DC power that goes directly into the battery bank, which means it doesn't go through a charging system. It goes directly into the batteries. So it's like a fast charging system. So if it's an 18 kilowatt genset, like the one in this picture, it's putting 18 kilowatts of power into the batteries when it's running, and it's not having to go through a charger. There's also no mechanical connection between the generator and the boat. The only thing coming out of it are the power cables and the fuel going in and coolant. But this is why people think, oh, but if I'm going with a hybrid system, then I'm still have a diesel on board. It's still going to be loud and noisy and smelly. And the reality is it really isn't, because there's no mechanical connection. There's no shaft. There's no sail drive. There's no gearbox. And as you can see, it's in its own soundproof enclosure. So it is far, far quieter having a DC genset. And it also means that there's far less wear and tear. There's a whole host of things around this. I wrote an article that is available on our website, or you can just email me and I'll send it to you, that explains what we mean by an Oceanvolt hybrid, because hybrid can mean many things. But what we mean with Oceanvolt hybrid is a DC genset, and I explain, all the pros and the cons and how it's set up in this article. But the short version is DC generator runs at a constant speed, which means it's optimized to run at that speed. So it's more fuel efficient. It's not wasting fuel at low speeds. And also because it's running at a constant speed, there's less wear and tear on the parts. So the maintenance is less. For instance, if you were to buy a secondhand car and there's two identical options, both done 100,000 kilometers, but one of them has done that on the highway and the other one has been in pretty low moving traffic constantly changing speed, you're going to be choosing to buy the highway every time, because there's far less wear and tear on the parts when it's just running, as opposed to changing speed and things like that. So the fuel consumption is far less of the DC generator, and it's far less a maintenance cost as well. So that also means that it's not running at the whole time. So for instance, I come to this graph here. So this is what we call a heartbeat graph. So on the y-axis here is the fuel consumption in liters per hour, and then on the bottom is the distance, obviously nautical miles. If you leave the harbour and you start motoring at 4 knots with your diesel engine needs to be running the whole time to keep going at that 4 knots. But with an Oceanvolt hybrid, all of the propulsion is always coming from the electric motor, and that is taking its power from the batteries. So when the generator turns on, it's typically providing more power than you're consuming, which means that it will charge the batteries whilst you're motoring along. So you start motoring, you're not using any fuel, then the battery level drops and the generator automatically switches on, charges the battery, consumes fuel to charge the battery, stays running, and then when the batteries get charged up to about 80%, generator turns itself off again. And you're still motoring at 6.5 knots without the generator running, which means it's not burning any fuel. So this is one of the main reasons why a hybrid uses less fuel than a traditional diesel. So this is a real graph. This isn't a projection. This is a real graph, real figures. And we have them from a number of our customers and things. For instance, there's a Swan 55, a beautiful 55-foot Swan, classic Swan, had a 110 horsepower Perkins on it previously, if I'm not mistaken, and I think a 900-litre fuel tank. And at 6.5 knots, he used to be able to go, I think it was 700 and something miles of range at 6.5 knots. He's now changed to an Oceanvolt hybrid with a shaft system, and he gets over 1,000 nautical miles of range now with the same size fuel tank. And then the other thing to keep in mind here is that when the generator is running, it's at a constant speed, so it's far less intrusive. And then when it switches, you have all this time here where the generator is not running, so it's a lot less intrusive and your comfort goes up. And then another thing to keep in mind is, again, we're trying to link all these systems together to make it all integrated. So the generator is charging the main battery bank, which is then supplying power for your whole boat. So you can use electricity as if you were at home, or you don't have to worry so much about how much power you're using. It's really taking a lot of the stress out of it, and just increasing your comfort. So there's far less diesel smell, far less diesel being used, which is good for the wallet and for the environment. And you can have all your creature comforts on board running as long as you like, and you don't even need to worry about it. And the system is all entirely automated. So you can trigger the generator on and off if you want to, but it is automatic. So when the battery drops, the generator turns itself on and charges up again, and it turns itself off. It's a really, really neat system. That brings me to charging. So there's a number of different options to charge your electric boat. Best joke I ever heard, and I hear it almost every day, is what's the range of my boat? How long do I need an extension cable? Very funny, but you do want to plug into shore power occasionally, or if you can, plug into shore power is a great way to charge. We can supply charging systems of a range of different powers. So depending on how large your battery system is and how fast you want to be able to charge, we can supply charging systems to suit your needs. But typically we would put a charger on that means you charge up overnight. Even from 0% battery, you'll get to 100 in 5 or 6 hours. The limiting factor mainly is the shore power capability. So typically it's 16 amps of power that's available on shore. So if you have a larger battery bank and you want to charge faster, but you don't want to be that guy that constantly causes a blackout in the marina by overloading the system, what we would do is we would supply 2 separate chargers that are smaller. So then you just have 2 plugs that you plug in, and that means you get twice as much power coming in. Hydro generating, obviously, another great way to recharge your boat. I say this with needs to be taken with a grain of salt. I'm not going to say that, if you have a little Sparkman Stevens 34-footer, you're probably not going to be able to recharge your boat through regeneration because you're not going to be able to sail super fast. So if you're thinking about, running your battery down to 10% and then charging it up with a couple of hours of sailing, if you have a very fast boat, then that's possible. Think catamaran or trimaran, but typical monohull or modern monohulls as well are very quick as well. But typically, it's sort of seen as I would look at it or view it as a top-up scenario for most typical cruising boats. But as I mentioned before, very dependent on the prop. Here's a little graph to show you how dependent on the prop it is. So this is a sail drive 10 kilowatt motor and a servo prop 10 kilowatt motor. So the motor is exactly the same. The leg is the same. It's an Oceanvolt system, both of them. Everything's the same boat, etc. The only thing that's different is it's a servo prop versus a regular folding propeller. And as you can see, the regeneration for the folding propeller is far less. So at 7.5 knots, you'll be getting 3 times more power with a servo prop. As I said, 300% better. So if you're really keen on the regeneration, I would seriously consider servo prop. Generator, again, just mentioned that it's not a requirement. We've got many, I would say almost 80% of all Oceanvolt boats around the world are pure electric. But I mentioned the generator because it really does make your boat better. Gives you more range and more flexibility, and it gets rid of that range anxiety. So that's the number one thing that even with electric cars, it's the number one thing that causes stress is the range anxiety. So if you're at all suffering from that, then what we would recommend is you go with a smaller battery bank and put a generator in. And that means that you can be much more self-sufficient and much happier. And there's other auxiliary sources of power as well. Solar power, we recommend everyone does solar. Wind turbines, I'm not a big fan of, but that's a very personal preference. Everybody has their own preferences. Essentially, what we would recommend is any power coming in should be at 48 volts. So your solar panels, your wind turbines, they do make 48 volt wind turbines, etc. But that's something to keep in mind. But like I said, one of the things we specialize in at Oceanvolt is we're not just selling systems off the shelf, we're doing entire system design. So when we get down to the nitty gritty, we can work out exactly how it all goes together according to your particular needs. And then we come to system monitoring. So checking to make sure everything works. We currently our systems come with sort of Victron integration and a Victron Servo GX. This is modified by us. So even if you already have one on board your boat and you want to refit, we would supply this because it comes with our own configuration on it to optimize it. So we can get all sorts of amazing data here. So this is a screenshot of a boat in the UK. If your boat connects to the internet, then you can get real-time data, but if not, then it can keep a log of the data on an inbuilt memory chip that then can be put up next time you connect to the internet. And you can really get pretty much any data that you want. So if you're interested in how expansive this can be, then send me an email and we'll have a separate call and I can take you through. For instance, Doris is a great example because they've got almost everything is linked into this. So you can see what your motor power is at any given time versus your speed of the boat. GPS is also in there, so we know where it is in the world. We can see how much solar there is. It's also hooked into the weather forecasting on board, so you can see what if there's cloud cover, the motor room temperature, the humidity, everything, absolutely everything. The battery health, individual batteries, voltages, currents, temperatures, everything can be here. And this is something that you as the customer and the boat owner have access to, and you can modify your dashboard to show various different things. And it's a really, really cool thing. So it also means that if you have a hybrid system that you park your boat, on a mooring and you go away on a trip to Europe or Africa or America for a month or something, and you can pull your phone out and see, oh, the weather's been a bit cloudy back home. I'll just check on my boat. Oh, the batteries are down to 42%. I'll just charge it up real quick. And from your phone, you can, tap and start the generator and then turn it off again remotely. And your boat can take care of itself. I used to demonstrate that feature at boat shows until I got a call from a customer saying that he was very shocked that his generator started when he wasn't expecting it. But it is very, very powerful remote monitoring system, and it is obviously optional. So if you want to keep yourself, a little bit more private, then that's totally up to you. That's fine. It is an entirely private and secured system, so that's not a problem. Maintenance. That's another fantastic thing that people, get excited about with electric, that it's virtually maintenance free, and honestly it is. Virtually maintenance free. So if you have a hybrid system, then the generator needs normal diesel engine maintenance, which is something that I'm sure everybody here is familiar with just from having your own diesels on board. You change filters every now and again, that sort of thing. However, the electric propulsion side of things is incredibly simple. So basically, keep your batteries above freezing point, not an issue for Australia. The key is to allow the system to continue monitoring. So a lot of people think, when you leave the boat, you turn everything off. But that's not the way to think about it in terms of a lithium battery or like a large battery bank. You want to leave the battery management system on so it can keep monitoring the system and keep things going. So that's something that will help prevent any potential deep discharges or damage to the batteries, etc., is if the BMS is running. And that also means then that you can set up remote alarms. So either you'll get a text message or a buzz on your phone or an email, or we will as well, that, hey, your batteries are actually starting to get quite low. They're at 10% now. Do you want to maybe think about going and plugging into shore power or something? So for that reason, we recommend you keep your BMS on at all times. As I mentioned earlier, we do regular software updates, which almost all of them can be pushed out remotely. It is optional. If you want to keep the existing, system and you don't want to touch it, then that's fine, not a problem. But if you want to get the latest and greatest, then we send that out. And currently those are, sent out for free. We push that out and update your boats for you. Because it's electric and electric motors are incredibly simple things, it means that 99% of problems can be resolved remotely by our team here in Finland. So if you have an issue, then you would book a time with our tech guys and make sure your boat connects to the internet, and they can log into your boat and see what's going on, see what the error is, see what caused the error, fix the issue and update you on what went wrong and how to prevent it in the future. So the maintenance and service is so much simpler. Really, the only thing you need to worry about is the cooling system. So if you have a seawater cooling system, then maybe the filter gets clogged. But if you don't want to have a seawater cooling system, we also offer an oil to air cooling system, which means you can close off the seacock in your boat. So if fewer holes in the boat, that's great, and it would be a closed system with like a small radiator and fan arrangement. So that means filter clogging is far less, and in that case, you would really only change the coolant every couple of years. Anodes still need to be replaced yearly, but that's every boat. And then if you have a sail drive system, then just like a diesel, there's fluid or like oil, in the leg that needs to be replaced. We typically recommend that gets replaced annually. If you have a smaller sail drive or servoprop system, so the 10 or the 15, or we also do sail drives in 6 and 8 kilowatts. If you have one of those, then you would need to lift your boat up to change that fluid. But if you have the new high power servoprop, then all of the service and maintenance can take place inside the boat whilst the boat's in the water. So even changing the leg fluid can be done inside the boat in the water, and everything's integrated in that system. So it's a really, really smart system. But then a shaft system, obviously, it's just all about the coolant. You change the coolant, keep it cool and dry and happy days. So the maintenance is far less. And we've even had a number of case studies of customers where they've found that after refitting their boat, just in general, cruising use here in Europe, in Denmark, so not even all year round, because it does get quite cold here in the winter, but they've managed to see a return on their investment in terms of overall. So the cost of the whole refit from diesel to electric, they've ended up seeing a return on their investment in as little as 2 or 3 years, because they're not having to buy diesel, they're not having to buy oil filters, etc., and things like that. So they're saving thousands and thousands a year by not having to buy fuel. Because when you buy a big battery system for your electric propulsion system, you're actually buying about 10 years worth of fuel. But to be honest, MG cycle life is over 4,000. So that means if you start your day at 100%, you drain it to 0 and then recharge it back to 100 all in one day. You can do that every day for 11 years before your battery dies, as it were. So that's a pretty fantastic amount of cycle life in fuel, which means, nobody really runs their boat that way except maybe a commercial operator. But yeah, it really is quite fantastic. There's a familiar face and a familiar boat for all of you, I'm sure. The Shearwater with Guido. So what are the advantages of for the user or the skipper? So number one, motor sailing is an absolute dream come true with electric propulsion. So you'll all be familiar with motor sailing. If the super light wind, you just use the engine to keep it going. That's not usually very pleasant in diesel powered boat, because in light wind there's not much noise from the wind, so you really notice the sound of the diesel kicking over, and there's not much wind to blow away the fumes. So it can be pretty unpleasant, plus the vibrations. But with electric, even if it feels like there's no wind, there's always a tiny bit of wind. So we really recommend motor sailing, because it can halve the amount of power that's required to maintain a certain speed. So say, for instance, your boat needs 5 kilowatts to be motoring at 5 knots. If you go motor sailing and put your sails up, that should be able to maintain that 5 knots whilst only consuming about 2.5 kilowatts of power. So it really makes sense to do motor sailing with an electric propulsion system. There's no range operating restrictions when you're sailing. Because you have that massive battery bank, it means that your house power and things is going to last you longer than you can imagine. Whilst you're sailing, it just simply requires a slightly different way of thinking when it comes to motoring. Just like with an electric car, if you try and use an electric car the same way that you use your petrol car, you're not going to be very happy. But with a very slight adjustment in the way that you use your electric vehicle, you can really get a lot of fantastic benefits out of it. Another great thing is the instant torque and power. So, for instance, low-speed maneuvering, you have instant torque with an electric system. So it really makes it an absolute dream to handle at low speeds. And again, that reverse power with servo prop is really impressive. Easy handling, so and that sort of ties into silent, because it is quiet. You can be maneuvering in the harbour without having to shout at your crewmates on the bow or anything like that. It's very, very quiet. It can even be a little unsettling at first and take a bit of getting used to, without having the engine noise to gauge how much power you have coming to you, because you can't hear it, obviously. So that's something that we tell our customers, like almost with a little smile, is just be careful when you're parking it the first time, because you may not hear how much power you're using. But yeah, because it is quiet, it makes it much easier to communicate on the deck. And the generator runs automatically when needed. So again, this ties into the idea that we don't just sell, or we don't like to sell just a propulsion system, and we certainly don't sell stuff off the shelf. What we try and do is we try and design a complete system for you that makes your boat better and more pleasant place to be, because there's this. It seems that there's has been a tendency in recent years, or in recent years, that boat owners are expected to become experts on so many different topics, from not just sailing, but also, polishing, how to maintain a diesel engine, all these sorts of things, loads for shrouds and ropes and winch care and all of that. So that modern boat owners are expected to be absolute geniuses. If you want to become an expert on electric propulsion, I'm happy to help. We're all happy to help educate and share the knowledge. We're not gatekeeping any of it, but we also, not everybody wants to do that. So that's why we try and design the complete power management system and the entire system for you. So you don't have to be the expert. You can just buy a system and know that it's going to work well, and we can design a system to meet your specific needs. And obviously it's nice to feel like you're doing something good for the planet, sustainable energy and hydrogeneration, etc. So why should you consider doing it now? Well, I mean, it's something that you don't have to do right now. I mean, I'm not a very pushy salesperson. That's not my style. But the more the more that I've come to understand electric propulsion, and how these systems and things work, to me, it seems a no-brainer, honestly. You get more space inside your boat, and you're taking away, a tractor engine from your living room, basically, because that's what a diesel propulsion engine is. So you get much more comfort, much more space inside. It means that everything is integrated, so the power management is really, really well taken care of. And as you can see with the remote monitoring and everything, it's all taken care of, and it's very simple and easy to operate everything on the boat and to understand it all as well. The maintenance is far less, and it means that there's sustainable development. So, for instance, if you were to, thinking about making change to electric, the things to keep in mind would be an electric motor, as it is very old technology. So the hardware is not really going to be changing very much in the future. So investing in the hardware now is a no-brainer, because most of the changes are going to be coming through the software. So the software is only going to get better as time goes on. The other thing that people are thinking, or maybe thinking about in terms of waiting for things to improve, would be batteries. Yes, batteries are improving, and they're getting better, and they're getting cheaper. We've recently just been able to lower the price of the batteries that we supply by a fairly significant amount, getting close to 20-30% reduction in price. And that's to reflect what the whole market has been doing. As soon as our suppliers dropped the price, we dropped our price as well. And typically, if you look at the lifespan or the development cycle of technologies, that final price drop to match the market is what signals sort of the winding down of the development of a technology. So to be completely honest, I don't foresee any major changes to lithium battery technology. I think that we are extracting about as much from lithium chemistry batteries as we will. And I don't see it getting much cheaper as regulations come in terms of the production of these batteries. It's probably going to get a little, the price may end up getting a bit more expensive. But then on top of that, the RYA, so the British Yachting Association, and the RCA are also proposing that if you're going to put lithium batteries on your boat, then they have to be type certified and have certain certifications, which will limit greatly the kind of batteries you can put on your boat. Which means if you do want to go down the route of choosing your own batteries and getting, the cheaper ones and taking care of that on your own, then your time might be limited, because typically Australia follows what England does in these sorts of things. And also there's incoming legislation on forbidding combustion engines in a lot of harbours and cities. So obviously Australia is probably going to be a little bit behind some of the European places on this. Amsterdam is already a combustion engine free zone. So all the boats in Amsterdam in the canals are electric. Copenhagen is very close to doing the same thing. There's many lakes and areas in Switzerland as well. Turkey is also banning combustion propulsion engines. So there's a lot of reasons to consider it. So if your diesel engine is starting to, get to its last legs or things like that, then it's certainly worth thinking about at least considering the change to electric, because if you commit to going with a diesel now, then you're probably going to have that engine for the next 40, 50 years maybe in the boat. And that boat may not be able to go to certain places. I would imagine that the first places that would be restricting combustion engines would be places like the Great Barrier Reef, the Caribbean, these sort of places that have wonderful natural habitats for our marine life. They're going to be protected fairly soon, I imagine. So it's just something to consider, at least. And if anyone is interested in it, then there's plenty of resources on our website, or you can just send me an email, and I'm happy to help answer any of your questions.